Okay, guys, good evening. Is my voice loud and clear? Just give me a confirmation.
It's
Yes?
clear.
Okay. Superb, superb. Because I'm in a different location today. So just wanted to check that. Okay, just a second. I'm just going to start our recording for the people who are going to miss the live session. Okay. Let me just start it. Superb. All right, here we go. So, as I said, I'm at a different location today, traveling. Okay, so welcome all the new members. Okay, let's welcome the new members in the team right now. Who are the new members in the session right now today, attending the session first time live? Just type me in the chat box, and we will welcome you with our warm heart. Okay, Haider is there, Bappy Day is there. Who else? Who else? Type me in the chat box.
Paras,
Yeah. Okay. Yeah, just type that in the chat box. Superb, superb.
Paras.
So everybody just type welcome new members in the community. Super. And let's begin the journey. What is our topic we are going to discuss today? Type in the chat box. It's very interesting topic. And this seems to be a basic topic, but it is very interesting. Okay. Yeah, what is the topic, by the way, guys? Just a second. I've just lost. Haji, बोलिए fundamental of statistics. Absolutely right. Absolutely right. Amazing. Take a second. Haji. So in the fundamental of statistics, let me just share my screen. Okay. And we are going to go for now why the statistics is important today. Let's go to the fundamentals of statistics and take it from there. Okay, let me put my phone in the silence so that nobody disturbs us now. So, what is statistics according to you? Type in the chat box. What is statistics? Then I'll explain you why statistics is important and where do we use it. Yes? What is statistics according to you? Yeah, whatever definition you know, just type in the chat box so that. Okay, used for data analysis. Very good. What else? What else? Yes. Collection and analysis of the data. Okay. और क्या? और बताइए. Just give me a second. Converting information to data. Converting data into information. Ulta likha. So we are converting data into information. Okay, not the other way around. Because data does not have meaning unless and until it is converted into some meaningful information. Okay. So that's why statistics is see, we are learning Six Sigma, which is a foundation. The foundation is statistics only. Why? Because in Six Sigma, basically, fundamentally, so in Lean, basically, we are going to use lesser amount of statistics, but in Six Sigma, we use more statistics. And what types of statistics we are using in Six Sigma? So, in Six Sigma, basically, what we do is there is a real life project we take, a real life problem we take, right? And we convert that real life problem into a statistical problem. Make a note of this. This is very, very important. This entire DMAX cycle is depending on this. So a real life problem meaning what? let's say attrition is a problem, machine downtime is a problem, then our sales is down is our problem, then our the average call handling time is very high, that is our problem. So there are various problems we deal with in our processes. So that is our real life challenge, real life process challenge. Okay. Then we convert that into a statistical problem. Write this down. So we convert that into a statistical problem. And there, what do you mean by converting into statistical problem? We collect the data. So around a problem, we collect all relative data. So the real life challenge, we convert into numbers. How big is the problem? Okay, is it time associated problem? Is it department associated? Is it season associated? Is it maybe some manager associated? What exactly is? So we collect all the relative data, and that's how we convert the real life problem into statistical problem. Then, with the help of the statistical and graphical tools, basically we convert statistical problem into statistical solution. Wow, that's interesting. So a real life problem into statistical problem we solve with the help of statistical tools, principles, fundamentals, software, etc., etc. And then we convert the statistical solution into real life solution. So this is what we do in our projects, especially the Six Sigma projects. Okay, in the lean, wherever the lean is there, when do we use lean? Whenever we have challenges like reducing the time, lead time, downtime, okay, reduction of inventory, reduction of wastages, team wood. Those are typical lean projects. VA and VA elimination, non-value added elimination. They're typical, what you can say, the lean projects. But what are the Six Sigma projects? Wherever we have more variation, defects, customer complaints, rejections, scrap, all these are typical Six Sigma related projects. Okay. So there we use more statistics. So in that, real life problem into statistical problem into statistical solution, and then statistical solution into real life solution. This is nothing but a DMAC framework actually. This is what we do in the DMAC framework. Clear, everybody? Just type clear in the chat box if you're clear with this. Simple? Clear? Just make a note of this, all the new members, okay? Because we are going to the fundamental level of statistics today, which is important for us into in solving challenges, okay? Very. Now, let me share my screen with my PowerPoint presentation, okay? I have a small PowerPoint presentation, which is, of course, it is from your green belt curriculum only. Now, statistics generally we use more in two phases, okay? So major phase is just upon brief of what? Sai Funny, I haven't understood that. Brief of this 4-step framework, is it? Real life problem into statistical problem into statistical solution, and statistical solution into real life solution. So this is the stages of DMAC framework. That's what we have just said. Okay. Now, what do we do exactly into the statistical part? That is what we are going to go. So see, our real life problem, we define that in our define phase. Understand this? Our DMAC framework, our real life problem or the project or the challenge what we have, definition of that is happening in the define phase. Now, when do we convert that into a statistical problem? We convert that into statistical problem into measure phase. That's why I'm starting with the measure phase. Okay. So in the measure phase, what we do, we collect the data, right? Now there are three types basically of measure phase. Okay. Now the main, what you can say, the main, objective or the main essence of measure phase is you can't manage what you don't measure. It's very, very important, very, very deep meaning of that. You cannot manage what you don't measure and what you cannot measure. I'll give you a simple example of your own monthly expenditure. If you want to have the control on your monthly expenditure, okay, start measuring them. If you do not have the measurement, you don't have the control. Are you understanding this? Yes. Now you can understand this. Everywhere, wherever there is lack of control in your process, you will observe that the measurement system around that is very weak. Nobody is measuring that. If you start a measurement system in place, you will get a fantastic result. I'll give you a simple example of this. I'll give a simple example to explain this phenomena. Now, one of the SME companies, a small and medium, enterprise, they were struggling with the scrap generation. It was an engineering company, and there were multiple machines like this. Okay, I'm just giving you a very simple example so that everybody, even a layman, also can understand. So let's say there are similar kind of machines, and after every shift, there used to be a weighing scale, and they used to weigh the total waste. Okay, and what happened was, their waste was increasing, their waste was going up. All right. So one of the, when we were discussing that, so one of the consultant actually went around the shop floor, and they found that instead of a big waste bin, they made a small change. You know what was the change? They just put, instead of a big bin, they just put small bin in front of all the machines. Now, instead of a big bin, they started measuring small bin at the end of the shift. And after that, they put a simple, whiteboard dashboard, simple. Okay. Machine A, B, C, D. Shift wise, what waste? Okay. So now shift wise waste, they started to track. Now they realize, okay, machine number B is generating a lot of waste. So they started focusing on machine number B. Are you understanding? And then accountability also. The person who was running that machine also was under focus. So this is the power of measurement. Okay. So wherever you have, a poor performance section of your process, just put a good measurement system, and you will find, without doing any improvement, without using Lean Six Sigma, you will find an improvement in that. Are you clear with that? Just type yes in the chat box. Are you clear? Just give me yes in the chat box. Just start a simple measurement system. All right. Salespeople jitne hain, just start putting a simple basic system. How many calls you have made? How many visits you have made? How many, closed today? Simple measurement system, daily or hourly, whatever is feasible to you. Okay, that will improve the performance. Okay, coming back to the next one. So what you not measure or you don't measure, you cannot improve. Also very important. Okay, now there are three basically types of measure. One is input measure, process, and output measure. Given a simple example of a cup of tea, okay, which is easily understood by everybody. What is the input, process, output? Everybody is aware of this. Just give me yes in the chat box. Every process has input, every process has the output, and there are something which is happening within the process. Yes, everybody understands this. So whenever, let's say this is a tea making process. In the tea making process, if you see the input measures, it is quality and quantity of water. Quality and quantity. So the objective is, let's say, test of tea, if you want to improve. Okay. So we first put what are the input measures. Now, if you remember, I mentioned earlier that in the measure phase, we will collect all the data related to our problem. Okay. Let's say if I want to improve the test of tea, if I want that test of tea to go up, then what kind of data I will collect? Okay. So first I will collect all the input measure data, which is how much quantity and what quality of water we are using to make the test of to make the tea. Okay. So quantity we have understood. We have simple to understand quantity, right? Which is in milliliter. Okay. Or the cup of water, whatever. And the quality also is there. Quality meaning it can be, the taste of the water can change if we are using UV water. The same taste will change if you are using the RO water. the same taste will change if we are using the Bisleri water. Are you understanding the difference? So everywhere, so it's not only quantity, but the quality of the water also will have impact on the taste of tea. Okay, same goes with milk. Are you understanding? So mother's dairy milk will have a different taste. The Amul milk will have a different taste. Cow milk will have a different taste. Buffalo milk will have a different taste. So quality and quantity will matter. Taste of the powder as well, the sugar as well, everywhere. Quantity of and quality both will matter, and we have to measure them. Which quality we are using and what quantity we are putting in. Okay, so we have to collect this data around this. So generally, whenever we collect the data, I always suggest, okay, if the data is available, collect at least 1 year data, because then we can actually go deeper into all the cycles, the seasonal trends, patterns, etc., etc., etc. Okay, whenever data we have to collect, whether it is a output related data or the input related data, collect 1 year data if available. If it is not available 1 year data, whatever maximum amount of data available, that you should collect. Okay. Now, if the data is not available at all, then we have to start collecting the data. Write this down. Very, very important. Now, why are we doing this exercise in the measure phase right in the beginning? Because if you found that the data is not available about some input measures, about some process measure, about some output measure, then we have to start immediately. We have to start collecting data, because generally Lean Six Sigma projects are of 3 months to 6 months duration, right? So at least during define, measure, analyze phase, we will have certain amount of data collection with us. Okay, so हमारे पास at least 1, 1.5, 2, 3 महीने का data collect हो जाएगा, that we can understand, that we can analyze, and then we can carry forward. Clear, everybody? Whenever there is no data in the beginning of the project itself, start collecting that data, whichever is relevant to your project. Clear? Just give me yes in the chat box. Whether it is useful or not, you don't know, but start collecting the data without any kind of pre-assumption. Okay, so make a list. What are the input measures? What are the process measures? What are the output measures? So when it comes to the process measures, the temperature, okay, the time to boil, how much time are we giving to brew that entire tea powder? And then if we are stirring that entire solution, how much time are we stirring? So that time also can be calculated. These are the process measures. And what are the output measures? The taste of tea, and if it is hotel, then order to delivery turnaround time. So all these are called as the output measures. Okay, so input, process, output. Let's do one simple example, okay, of your own process. Okay, so have you understood this basic funda? Just give me yes in the chat box. Just give me quick yes. Everybody understood now? Yes. Now let's do this. Let's connect with your own process. Okay, whichever process you are working. Okay, select one area. What are the input measures? Now measures, now understand this. Measures meaning it should be something measurable. Understand this. When I say quantity of water, it will be 2 cup or 1 cup or 50 milliliter. It's a measurable thing. Okay. When I say process measure, temperature, it is 90 degrees centigrade, 100 degrees centigrade. It's a measurable thing. When I say output measure, it is a test of tea, which is on the scale of 1 to 100 or on the scale of 1 to 10. It's a measurable rating. So whenever we are writing this, it should be measurable. So now what we'll do is, in your process, give me one input measure like this. Okay, one input measure, one process measure, and one output measure. Everybody? So I've just sent it in the chat. So in input, just give me one example of in your process, what is the input measure which you measure? What is the process measure which you measure? And what is the output measure of the process which you measure? Type in the chat box quickly. This is exercise, very important exercise. Don't skip this. Okay, this will clarify. If you can understand this, then you have understood the concept. I'm just reading that, and everybody else also will understand from your, because we have people from all the other departments and industries, etc. नो, ये पूरा तीनों का एक साथ लिखो. इनपुट लिखो, देन शिफ्ट एंटर दबाओ, प्रोसेस लिखो, देन शिफ्ट एंटर, आउटपुट लिखो, देन सेंड इट. डोंट सेंड वन बाय वन. Shift enter. Remember, shift enter. Input dash, put that input measure, shift enter. It will be process center, then shift enter, then output. Okay. See, the live sessions are for the practical, deeper understanding of the concepts. Okay. So if you can connect it very easily with your own example, that will be great. Chaliye. Cups, preform, closure are input. Okay. Closures are input. Okay. Now, some of the nomenclature we may not understand because we are not from your industry. Okay, efforts in mandates to write the code. That's the input measure. Okay, effort in mandates. So mandates is a measure, right? Very nice, super. And process you have not written. Output is bug-free code. Okay, but what in the bug-free code, is the measure? Is it the number of bug-free codes that is the measure? Then it is number of bug-free codes that will be a measure, okay? Input measure is diameter of forging billet. Process measure is temperature and output is cycle time. Very good. Input number of resources support. Issue resolution. Process measure is issue. What is process measure? Not the process. Huh? Process measure we are talking about. Turnaround time is the output measure. Fantastic. Input is preforms, closures, label, water, shrinkage. Process is filling, labeling, shrink. And output kya hai? Input is cup wire diameter, process winding tension, and RPM of the tool. Fantastic. Okay, output is PQI and BQI. I don't know what is PQI and BQI. Maybe you can just write a full form of that as well. Okay, input is OOS, OOT deviation. Okay. It is, I think, out of specification, correct? And deviation. That's what I have understood. OOS is out of specification. Root cause and solution process. So this is measures we are talking about. Okay, what are you measuring in your process? It has to be a measurable aspect. Okay, output is action taken. No, this is not input process output, Sridharji. So what are we measuring in our process? Okay, so that is what we are writing here. Yeah, number of sales calls can be a measurable aspect. Clients visit, very good. Sales call open and number of leads called. Fantastic. That's a fantastic way. It has to be a measurable aspect. It should not be a process aspect. Okay. Beverage quality index, product quality index, and customer rating. Very good. Super. Net promoter score is an input. Very good. So I think you have understood by and large what is input, what is process, and what is output. Yes. Yeah. New hire training. Okay. Process is coaching staff. Again, what are we measuring? Is it number of training programs? What are we measuring in that? That is most important. Are we number of training programs are we measuring? CSAT is perfect. Is the output perfect? But in the training, what are we measuring? Is it number of training program? Is it rating in the training program? What exactly is the input measure? Coaching and feedback is a fantastic process measure. But input measure थोड़ा सा clear होना चाहिए. Siphoning, okay, for you. Raw material, OD size, process measure, feed rate, finish out. Fantastic. I think you have understood everything. That's what I can make out from your. So once we have collected the data, then what we do, there are two types of data basically. One is continuous and one is discrete data. Okay. So continuous data, which is measured data, and the discrete data, which is counted data. All right. So I think, yeah. So let me just give simple examples of continuous data and the discrete data is, continuous data is the data which is measured. So, okay, let's go to a whiteboard and let's make two parts of it. One is continuous and one is discrete. Okay, for the senior members, it will be a revision, but the new member, it will be something very interesting. Okay. When we start collecting the data, we'll come across two types of data. Okay. One is continuous and the other one is called discrete. Okay. What is continuous? Now, continuous data which is measured, and discrete data which is counted. Write this down. All right. Now, when we say continuous data, it is measured on continuous scale. Continuous scale. Okay. And discrete data is basically counted on discrete scale. What is discrete scale? I'll give you example of this. Okay. Discrete scale meaning 1, 2, 3, 4, 5. It is called discrete scale. What is continuous scale? 1, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9, 2, 2.1, 2. It is continuous scale. Are you understanding this? Are you understanding the difference between a continuous scale and a discrete scale? Just give me a in the chat box. So continuous scale is continuous. So example is height. Okay, we measure height, no? 5.1, which is 5 feet 1 inches, 5 feet 2 inches, 5 feet 3 inches, 6 feet 1 inches, 6 feet 2 inches. So height है, speed, temperature, pressure, all these are continuous data. On the other side, discrete data is, pass, fail, how many pass, how many fail. So we count, right? How many male, how many female. All these are, height, speed, mass, volume, all these are continuous data. And pass, fail, male, female, number of data points. Okay, number of color, which color? It's again discrete data, not continuous data. Okay, clear? Everybody's clear? That's why we are in the chat box. So generally what happens is continuous data gives us more information than the discrete data. Remember this, okay? So always continuous data is preferred over the discrete data. Super. Very good, very good. So right now in the chat box, just type one continuous data in your process and one discrete example in your process. Type in the chat box quickly. Give me one continuous example and one discrete example in your process. Yeah, just like this. Okay, for example, write continuous, write just C. Okay, let's say temperature. So temperature, and then I will write discrete, number of employees. So this is example of continuous में क्या आएगा? Temperature. If we are measuring temperature, it's a continuous data. If you are measuring how many number of employees per shift we are working, it's a discrete data. Clear? Super. Yeah, time is a very time थोड़ा सा नटखट measure है. Okay, just let me ask the question. Is time continuous or discrete? Type in the chat box. Time क्या है? Continuous है कि discrete है? Time थोड़ा सा नटखट है. नटखट बालक है वो. Yeah, type in the chat box. Absent, present, it's a discrete data. Continuous, okay, time is continuous. All right. So what is Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday? What is this? What are we measuring? But it is a measure of time, isn't it? Day is also a measure of time, right? Let's say 2 days, 3 days, 4 days, 5 days, 6 days. So now time, understand this, that whenever time is there, now understand this, time is natkhat balak hai. Okay, just like our our quantum physics, whenever we see that particle behaves like a particle. When we do not observe that particle behaves like a wave. That is the quantum physics theory. Similarly, the time, whenever the time is in milliseconds, seconds, minutes, hours, etc., it behaves continuous. When it is crosses the days mark, okay, days, weeks, months, years, decades, centuries, it becomes discrete in nature. Are you understanding? Just type yes in the chat box. Because then we count, na? How many months, how many years. Okay, but in the initial phase, milliseconds, okay, even nanoseconds, etc., etc., it's a continuous data. All right, so it behaves in both directions. Clear? So which one is our, that will define whether it is a continuous time or a discrete time we are offering. Okay, clear hai? Super, super. Chalo, आगे बढ़ते हैं. So let's introduce ourselves to statistics. What is statistics? The simplest definition of statistics is a science, okay, which converts data into information. Make a note of this. Very simple example written by me. Statistics is a science which converts data into information. We don't, comprehend the data as such. But if we convert that data into some graph, into some statistics, then we can basically infer out of it. That is why statistics is a science which converts data into information. Okay. Now, so when we say statistics, there are two types of statistics. One is called descriptive statistics. Make a note of this. Just take a screenshot of this. This is, by the way, available with you as well. One is descriptive statistics and other is inferential statistics. What is descriptive statistics? I always give example of, okay, a cricket match being played. A simple example. Now understand this, the senior people who are into black belt, master black belt, or you want to become a consultant, okay, just see how consistently I am giving only one or two examples consistently. If you're observing me for last 1 year, I'm giving certain examples who are very consistent. Are you observing this? Who are the senior members who are attending the sessions for last maybe 3 months, 4 months, like that? Just type me in the chat box. Somebody must be there, right? Correct? So the people who are attending this, yeah, the cricket example, I give this example on yellow belt. You would have seen me. The same example I will give. Okay. Now understand this. For you, now the mantra is for you, it is regular. Okay. Ha, Rahul Pant. ये सब example. For you, it is regular. It is repetition. But for the students, but for the audience, it is the new thing. Are you understanding? Just type yes in the chat box. Are you understanding this? So sometimes you feel like, अरे यही example क्यों देना है? But because it is time-tested example, for you it is repetition. You might become bored, but the person who is listening, that person is listening this first time. Okay? So make sure that आपको जो भी एग्जाम्पल देने आपके पास पक्के रटे हुए एग्जाम्पल होने चाहिए. एज ए ट्रेनर, ओके, आपके पास कुछ एग्जाम्पल्स फंडामेंटली पक्के सीमेंटेड एग्जाम्पल होने चाहिए, okay, while giving the training, okay, so that you can easily navigate through that example very easily. Okay, yes. Yes, revision, exactly. So no, for you sometimes, for a trainer ना कभी कभी बोर हो जाते हैं आप, you know, अरे वही एग्जाम्पल बार बार क्यों देना है, लेकिन for that person it is a new time, the first time, right? Anyways, coming back to descriptive statistics, when you are watching the match, cricket match, let's say T20 का match चालू है, then you see the 5 over score. The score is 40 runs for 2 wickets. Now this 5 over snapshot of the score, it's called descriptive statistics. Descriptive is about the sample meaning if 20 over is the population, everybody understand the population and sample, right? Sample is a subset of the population. Are you understanding? Population meaning the entire data set, sample meaning a small subset of the data set. Everybody is clear with the differentiation? Sample and the population, just type yes in the chat box. Are you clear with this? Just type yes in the chat box. So now let's see, if I cook the rice, in the cooker, all the rice grains are the population. But whether that rice is completely cooked or not, I will not eat the entire rice and check. I will just take one small tiny part of it, a sample. Similarly, in the quality checking department, QA, QC people, they check the sample and they check whether the sample is adhering to the specification limits, correct? So this is descriptive statistics, which is basically about the sample. This is about the past, because 5 overs have happened, 5 overs have gone, it has become the past. In the same cricket match, you would have seen projected score. How many of you have you seen this projected score, which is, there is one line which comes up that the projected score is, let's say, 160. If they score with 8 runs per over, they will score 160. If they score 9 runs per over, they will score 180, etc. This is called projected score, yes or no? And this is called inferential statistics. And this is about the population, and this is about the future. If this is a sample, then how the population will behave, that's kind of a prediction we are making. That's kind of an extrapolation we are making. And this is what we are doing in the statistics. So statistics is science जिसमें हम लोग सैंपल लेते हैं, सैंपल को एनालिसिस करते हैं, and we predict about the behavior of the population. Clear, everybody? That is called inferential statistics. So descriptive is about the past, about the sample, and inferential is about the future prediction about the population behavior. Clear? Super clear. Just give me yes. Very nice. Okay, so inferential statistics में आता है hypothesis testing, regression, design of experimentation, 95% confidence interval. All these things come into the inferential statistics. It is prediction about the behavior of the population. Okay, of the future reference to the present. Fantastic. That's very nicely put, Shantanu ji. Okay, and descriptive is what has exactly happened. Like, for example, when we have the viral fever, our doctor suggests the the urine or the blood sample testing. So now generally we have 5 to 6 liters blood in our body, right? But the pathologist does not take out all the 5 to 6 liter body blood, right? Otherwise we will not be alive, correct? So they take a small sample blood, which is a descriptive, and on the basis of that they analyze whether what is the infection in entire body. Are you understanding? So this is a fantastic example of, by taking the sample, whatever they analyze, okay, that report is the descriptive statistic of a sample. Accordingly, the doctor, the physician, judges whether what kind of infection is there, what is the percentage of infection in the entire body, and according to the prescription is given. Okay, so prediction about the entire body is the the inferential statistics. All right. Now, coming back to descriptive, there are two parts. One is central tendency and other is dispersion of the data. Okay, what is central tendency and what is dispersion? Let's understand this with a simple, again, the same example which some of the people have written earlier. Now let's take a case of there are 2 wicketkeeper batsmen. Now this is, in the current Champions Trophy, this is a dilemma for cricket selectors. What is the dilemma? You know that? Whether to select Rishabh Pant or whether to select KL Rahul. Are you aware of this? Now there is a Champions Trophy which is going to come. And now these people are in the dilemma whether to select Rishabh Pant or whether to select KL Rahul for the 50-over cricket matches. Right? Now, the challenge is, what they will do, let's say Ajit Agarkar is the selection committee person. Now, what he will do first, he will collect the, the average of Rishabh Pant, and so he will collect the data, the score, last score of 30 matches of Rishabh Pant and last score of the 30 matches of KL Rahul. And then he finds that, okay, Rishabh Pant has also scored with 40 average, Rahul is also scored with 40 average. So they are at par, their skills of wicket keeping, let's say, are equivalent. Let's say Pant is scoring at 40 average and Rahul is also scoring at 40 average. Then what they will do is, they will go for standard deviation, which is sigma. Okay. Now there, we will see Pant standard deviation is 15 and KL Rahul's standard deviation is 5. So if I draw this on the, on a graph, it will look like this. If I draw the Pant's graph, it will look like this. Understand this, okay? Let me use a white one. Oh, okay. So Pant's graph will look like this, whilst KL Rahul's graph will look like this. How many of you have understood this? And the average is 40. This is center. But this is Rishabh Pant, where the standard deviation sigma is equal to 15, and this is Rahul, where standard deviation is 5. Have you understood this? Just type yes in the chat box. Have you understood this example? Clear? So when it comes to average, this one, it is a part of central tendency. Make a note of this. Okay. So here we are checking what is the central tendency, what is the center of the data line. Okay. Yes. Now, if the central tendency is, say, the similar kind of, what I can say, performance, because both are scoring, their X bar is 40-40, then they go for the variation. So this is dispersion is nothing but a variation. Okay, then they find out this standard deviation, where they found the Pant standard deviation is 15 and Rahul's standard deviation is 5. So they will select KL Rahul because he is very consistent. So how do we read this? So Pant will score, sometimes Pant will score 5 runs, sometimes Pant will score 60 runs. But KL Rahul will be very consistent between 35 to 45, 35 to 45. Are you understanding this? Are you understanding? So the variation is less in the KL Rahul. So consistency is very nice in case of KL Rahul. So KL Rahul becomes a predictable player. So selector will go for KL Rahul. I'm just giving you example, okay? What they will do in the Champions Trophy, I don't know. Are you clear with this? Just type yes in the chat box. Clear with this example? So central tendency, there are 3 measures here: mean, mode, and median. And the dispersion, we have 3 measures: range, variance, and standard deviation. Clear? Just take a screenshot of this. Just take a screenshot quickly before I just take it to the next one. Clear है? तो अभी हम लोग सिर्फ मीन मोड मीडियन को देखेंगे, बाद में हम लोग इसमें जाएंगे, मिनिट ऐप पे जाएंगे, मिनिट ऐप पे. ओके, मिनिट ऐप पे भी करके देखेंगे. ठीक है, चलिए. सो लेट्स गो टू फंटास्टिक. चलो तो लेट्स गो टू, सो डिस्क्रिप्टिव इन्फरेंशियल देखा हम लोगों ने. लेट्स गो टू द सेंट्रल टेंडेंसी. द फर्स्ट इज कॉल्ड मीन. ओके, सो सेंट्रल टेंडेंसी के 3 पार्ट है: मीन, मोड, एंड मीडियन. So mean is a simple arithmetic average. Okay, so which is nothing but, so if these are the production numbers of 5 days, so we'll add them up and divide by 5, which is, let's say, 650. Simple arithmetic average is called mean. All right, now let's come to the next one, which is called mode. Mode is the maximum frequently occurring value in this data set. Maximum frequently occurring value. So now let's see this data. Which value is maximum frequently occurring value? Type in the chat box quickly. Which value is maximum frequently occurring? Exactly. So 75, right? So because 75 is coming once, twice, and thrice, that's why 75 is the mode. Clear hai? All right. Now let's say here is 80 also is 2 times. 1 and 2. Can you see there? 80 also is there for 2 times. Let's say there is another data point called 80. After 67, there is 80. So 80 also will become 3 times. In that case, there will be 2 modes. Okay, so 75 and 80, there will be 2 modes, and that is called bimodal distribution. Clear? Everybody clear with this? So if I draw this bimodal distribution, it will look like a camel back. Camel का जो back होता है ना, उस तरह से. This is 75 and this is 80. So if I draw this histogram, let's say 1, 2, 3. So 75 is also coming 3 times and 80 is also coming 3 times. Are you clear? This is called bimodal distribution. Are you clear with this? Just type yes in the chat box. Clear? Even though it might be symmetrical, but this is not normal distribution. Okay? Very good. So normal distribution is always a unimodal. Unimodal meaning only one mode in that. Now, in case if we have all the data points exactly of the same frequency, let's say all the data points only once, then what will be the mode in that? Imagine kariye, all the data points are only occurring once. What will be the mode in that case? So it will look like this. The frequency is 1, right? So it will look like this. Everybody, what will be the mode of that? Priyanka has already given the answer, but I'm expecting more answers, right? Boliye. Type in the chat box. Exact middle data point, okay? Correctly. See, here we are learning, okay? Uniform distribution. Very good. So it is called no mode. That means there is no mode. If there is, no, in this case, it is called no mode or uniform distribution. This distribution is called uniform distribution. Okay? Clear? Multimodal meaning anything more than one. Okay, so 2 modes, 3 modes, 4 modes. Okay, bimodal, trimodal. That is called multimodal distribution. But it is not normally observed. So generally it is called mode. Mode clear hai? So mean clear, mode clear. Yes? Let's go to median. What is median? Now, when the data is arranged in ascending or descending order, whatever comes in the center, no, highest minus lowest is called the range. Okay, that is the measure of the variation. Now we are talking about the measures of the central tendency, mean, mode, and median. Okay, now when we arrange the data set in the ascending or descending order, whatever is coming in the center point, that is called the median. In this case, if we arrange the data set in the ascending order, okay, this value is the central value in the data set. Imagine, so it is very easy to identify the median in the in the odd numbers, because there are 7 data points. That's why there is only 1 data point in the center. What will happen if I add another value here? Let's say if I add 50 here. Now we have got 8 data points. So what will be the median in this case? So I've got 2 values here in the center. Are you understanding? And not only 1 value. I've got 2 values in the center. In that case, what will be the median in this case? Type in the chat box. 19 and 25. Okay, what else? So median is the central value, okay? Midpoint of these two, bimodal. No, ये mode नहीं है. Bimodal comes in the mode. When we have 2 modes, that is called bimodal. Right now we are talking about median. It's another value. ये अलग है. Okay. So in this case we take exactly, you're right. So we take average of these 2 values. So we'll take average of 19 and 25. Okay. Which will be 22. So 22 will be the median in this case. Are you clear? So whenever we have the odd number, there will be central, only 1 value will be there. Whenever we have the even number, we have to take average of the 2 central values, and that becomes the median. Clear? Just type yes in the chat box. Now, the obvious question which comes is, why do we use median when we have mean? Correct? तो median की क्या आवश्यकता है? एक example लेके समझते हैं. All right? Now, mean is the highest, what you can say, more frequently occurring, what you can say, used value is mean. But when do we use median in that case? Now, let me give you an example of, let's say, there are 5 people, okay? Imagine there are 5 people. Now, you have to pull out your calces, okay? and we will calculate the mean and the median. Understand this, okay? Imagine there are 5 people salary in lakhs per annum we are taking, okay? So the 5 people are, first person has got 6 lakh rupees, second person has 7 lakh rupees, third person has 9 lakh rupees, fourth has got 10 lakh rupees, and the fifth one has got 12 lakh rupees. All right. Can you calculate the mean and the median of this? Type in chat box. Calculate करो और type करो. Mean क्या है? उसका simple average लेना है. Median क्या है? Arrange them in the ascending order. I have already arranged it. What is central value? That is your median. Okay. Calculate करो. So these are the, the let's say middle level management. एक छोटा company है, उसके middle level management की salary है ये. ठीक है? Just type in chat box. What is the mean and what is the median? Mean is what? 8.8. I'm not calculating. I'm just believing on you. And median is 9. Everybody got this answer? Just type yes in the chat box. Yes, everybody got this? 8.8 is the mean and median is 9. Got it? Right? Now, this is the first scenario. Let's, in the second scenario, for the same company, there is a CEO of the company which has got the salary of 1 crore rupees. Okay, which is 100 lakhs LPA. So, now let's calculate this. Now the last one is 100, which is kind of an outlier here. Now calculate the mean and the median here quickly. What is the mean and what is the median? Now it's a even data now. Data was easy. 9 was the central value, right? Yeah, what is the mean? Is it exactly? या कुछ डेसिमल में आ रहा है? 24 भी आ रहा है? 20.0. And what is the median? Yeah, mean is 24 and median is 9.5. Everybody got this value? Because value is in the center, so the median is 9.5 and the mean is, add all them up and divide. Everybody got this? Now, what is your observation? What is your observation? Type in chat box. What's here in this case? Think about it. See the data in front of you. And what is your observation? Type in the chat box. Think about it and type in the chat box. What is the observation here? Very interesting observation. That will clarify why the mean and कोई भी observation नहीं है. Mean gets influenced by outlier. Fantastic. Median not changed far. Very good. Very nice. Now, whenever, okay, understand this. Whenever we have a normal distribution, okay, when we have normal distribution, there are no outliers. Generally, there are no outliers, okay? But whenever we have skewed distribution, what is skewed distribution? This will be like this, okay? This is called skewed distribution. So there are outliers here. Now write this down. Whenever the data is normally distributed, use mean to demonstrate your central tendency. Whenever the data is non-normal or skewed, this is called skewed distribution. See, whenever we added the CEO salary, it has become an outlier. It has become a skewed distribution of the data. Then we have to use median as our central tendency data point, because median does not immediately get influenced because of the outlier, but the mean immediately got influenced because of the outlier. Have you understood the? Just type yes in the chat box. So whenever the data is normally distributed, go for mean. Whenever the data is skewed distribution, go for median. Are you clear? Just type yes in the chat box. Clear hai? Super clear. Amazing. Now let's go to, so mean, mode, median, funda clear? What is mean? What is mode? What is median? Clear hai? Do we have to calculate it manually? No. I will show you how to calculate on the Minitab as well. All right. Chalo, let's go to, now median is there. Now let's go to dispersion, which is the spread of the data. Okay, how does data is spreaded? Correct? वो कैसे measure करेंगे? There are three ways: range, variance, and standard deviation. Okay, so the first one is called range. See, now mean, mode, median is the central tendency, where the center of the location, of the data set is concerned. That is called mean, mode, median. Now, what is the dispersion? ये data का spread कितना ज़्यादा है, वो देखने के लिए we have range, variance, and standard deviation. So, what is the range? The simplest way is the range, the lowest value, the highest value minus the lowest value. Okay, let's say for example, if we take, let's take the, everybody just type your height in the centimeter in the chat box quickly. Let's put your height in the centimeter in the chat box quickly. Fatafat. 175, 162, 162, 157. Okay, type in the chat box 150, 175, 162, 175. Okay. Super. So who is the tallest here? Yeah, I think 178. Super. So let me put my height as well. Okay, 180. Superb. So we both are 180. So we are the highest one, correct? So what is the range? 180 minus, I think the shortest one would be 150, right? So the range of the data set is 180 minus 150, which is 30 centimeters of the people sitting in the room. Are you clear with this? Just type yes in the chat box. Clear? This is called the range. Highest value minus the lowest value is called the range. Clear? Amazing. Amazing. Super. Now let's calculate the standard deviation. Okay. And variance as well. Variance and standard deviation दोनों calculate करेंगे. Okay, let's take this example. Now this example we use in the hackathon as well. So the people who have attended the hackathon know this example. But in the 5 minutes, this example will clarify what is variance and what is standard deviation and how it is calculated and what is the meaning of that. Okay. So let's take this example. These are the data set 10, 12, 15, 18, and 20. Okay. Let's say we have taken the 5 data points randomly. Because why 5? Because we have to calculate it manually. That's why 5. The first step is to collect the data. Second step is take the average. And the average is 15. So we add them up, divided by 5 is equal to 15. Okay, 75 divided by 5. Then calculate the deviation from that average. Now, for example, now this is very, very interesting. What is standard deviation? First, we collect the data. We take a reference point, and the reference point is the mean. Okay. So in the second step, we calculate the mean of the data, and that mean becomes our reference point. From that reference point, now understand this, from that reference point, what is the average value of each and every data point? It's called standard deviation. Simple. Logically, एक बार imagine करिए इसको. If we have the data spread across, we collect the mean, which is a central value. Okay. Now, from the reference central value, what is the distance of each and every data point on an average? It is called standard deviation. Have you understood this? Just type yes in the chat box. Have you understood this? Just give me yes. Yeah. So from that reference point, what is the on an average the distance from each and every data point? Okay. So more the distance, more is the variation. Lesser the distance, lesser the variation. Okay. I'll repeat again. Okay. Now, listen to me very carefully. First, we'll collect the data. First, we'll calculate the mean of the data, average. Why do we calculate the average? To get a reference value. See, deviation निकालने के लिए we have to have a reference value. No? From there only we will calculate the distance. Correct? Now, for example, if you want to measure the distance between Mumbai and Delhi, so there are two reference points. Like Mumbai, there has to be a reference point, and Delhi, there has to be a reference point. Then only we can calculate the distance, right? Similarly, to calculate the standard deviation from each and every data point, from which point? From the mean. Okay. So first we calculate the mean, and from that mean, from that reference point, from the central reference point, what is the distance of each and every data point? It's called standard deviation. Clear? What is the average distance of each and every data point from the mean? It's called standard deviation. Clear? Just type yes in the chat box. So let's calculate this. Okay. Now, step number 3 is calculate deviation. Now, we will calculate a deviation from the mean. Okay. Now, listen to this. The first point is 10 and the mean is 15. Okay. So, this is the mean value. Now, we are calculating the distance between these two values. Okay. So, what is the distance? It is 10 minus 15, which is the distance is minus 5. Everybody with me? So, distance is minus 5. The second value is 12 and 15. The distance is minus 3. The third value is 15 minus 15, which is 0. The fourth value is 18 minus 15, which is 3. And the fifth value is 20 minus 15, which is 5. So it's just exactly symmetrical. So we have taken the deviation. Okay, so there are negative values, there are positive values. If I take the average of this average will be 0 because the minus and plus will clash with each other and will not give us the right value. That is the reason the statisticians take the squared value of this, because the squared value is always a positive value. Yes or no? Correct? So what we do is just take a square value of this. So minus 5 square is 25 and not minus 25. Okay. Then we take minus 3 square is 9. Then 0 square is 0. Then again 9 and again 25. Okay. So we have taken the squared value of all these deviation, and now we will take the average. Okay, can you just calculate the average of this? 25 plus 9 plus 0 plus 9 plus 25 divided by 5. Can you just take the calculation? Do the calculation, give me the answer in the chat quickly. Yeah. Type that and give me the answer. 13.6. Everybody got this answer? आप खुद करिए, okay? So 13.6. Now this is called variance or sigma square. Write this down. Variance or variance. Some people call it as variance as well. V-A-R-I-A-N-C-E, variance or variance. Okay. Why it is sigma square? Because it is a squared deviation ka average, right? It's a squared value ka average hai. That's why it's called variance. And to calculate standard deviation, we have to take the square root of this. Can you just take the square root of variance? Square root of 13.6 ले लीजिए. What is the square root? Type in the chat box. 6.8 नहीं आएगा ना? 13.6 का. Is it 6.8? Is it? No, it will not be 6.8. It will be, yeah, 3.68. Yeah, that will be right answer. Because 6 का square itself is more, right? So 13 तो नहीं आएगा. It's 3.68 or 3.6, I think. 3.68 or 3.6, whatever. So let's say 3.68. So this is called standard deviation. This is called standard deviation. Now, what is the meaning of this? Now, let's try to understand this. Okay. Let's try to understand this. So, on an average, each and every data point is 3.6 units away from the mean. On an average, each and every data point is 3.6 units away from the mean. On an average, if you have taken the distance, on an average, this is 3.6 unit away from the mean. And this is called standard deviation. More the standard deviation, more is the spread of the data. Lesser the standard deviation, lesser the spread of the data. Clear, everybody? Just type yes in the chat box. Are you clear with this sequential way of calculation? Now the standard deviation has the same unit of the data set. If the data set is in centimeter, standard deviation will be in centimeter. If the data set is in degree centigrade, standard deviation will be in degree centigrade. Write this down. If the data set is minutes, standard deviation will be in minutes. Clear? Just give me yes in the chat box. Are you clear with this? Everybody? Any question? Super. Now, I'll give you a small, look at this. Here, there are 3 examples which will even clarify this. N is equal to 23. N meaning number of data points. Okay. N is equal to 23, which is, if you see here, there are 23 data points. You can count this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So there are 23 crosses. And this is a histogram. And if you connect this histogram, this has become a normal distribution curve. Okay. Or bell-shaped curve, we call it as. X bar is the mean. The average is the mean, this one. Okay. And S is standard deviation, which is 1.75. Now, in the second scenario, this is the first scenario. This is the second scenario in which the spread has reduced. Okay, you can see the spread has reduced. It has come very close to this. Okay. Now, there are more number of data points in the center. In this region, there are more number of data points. So the process has become a little centered here, and that is reflecting in the standard deviation, where the number of data points and the mean is same. Are you understanding this? Just type yes in the chat box. So mean दोनों का भी same है, but standard deviation different है. Standard deviation कम हो गया है, so the spread of the data set is reducing. And let's see the third option, where the spread has further reduced, the same data points, same mean, and the same average at the 5, but the standard deviation is 0.85. Are you clear with these 3 examples? Just type yes in the chat box. Super clear with this? Now, how do we calculate? How do we calculate with the help of Minitab? Okay. चलो Minitab पे करके देखते हैं. I'm just sharing a data file, or you can just open any random data file if you have. Let me open that. Okay. So I've just shared one file in the chat. You can just check that. And once you open that, let me know in the chat box. Okay. Yeah. I'm just waiting for response. Open. Or you can open any blank file. It is also okay. Very good. Super. Now, so here, what we'll do is, let me also open this file. Now there is some chocolate with file. Okay, even last session also we have used this file. Okay, so how do we find this standard deviation, mean, mode, median? There are multiple ways actually you can do this. I'll show you a couple of ways today. There are multiple ways. One way is display descriptive statistics. Can you see this? Stat, basic statistics, display descriptive statistics. If you can check out that. Go to stat, basic statistics, display descriptive statistics. Click on that. Put the chocolate weight in the variable option. All right, put the chocolate weight in the go to statistics and just select what you want out of it. Okay, there are a lot of statistics available here. Okay, so if you want, let's select all. Okay, so जो important हम लोग देख लेंगे. Select all पे click करेंगे. यहाँ पे नीचे देखिए all. It will select all the statistics and say okay and say okay. All right. Once you click on OK, it will open. Everybody has got this. I'll also do this. Just type yes in the chat box. सबको मिला है ये? या मैं रिपीट करता हूं, एक बार फिर से देखिए. Open the file. I'll go back to the data. This is the data. Go to stat, basic statistics, display descriptive statistics. Okay, Sadanandji and Sudhamji, just follow this. Let's go to stat, basic statistics, display descriptive statistics. If you don't have Minitab right now, just observe and then just check the recording later and try this on your own. Okay. Once you select display descriptive statistics, click on that. Here in the variable, select the chocolate weight. So यहाँ पे आपको double click करना है. If this is not there, double click here. Okay, this will come. Double click on that. It will get selected. Go to statistics. Here, this window, and select all. As of now, just select all. हमें all की जरूरत नहीं है, but select all just for our understanding. Just click OK and click OK. You will get this. Okay. Now you will come to this. So here there are a lot of statistical data. What we are interested in this. Total number of data points are 120. It's called N. Okay. Yes. Total number of data points are N, which we have seen. Now this is something like N asterisk, which is called N missing. अगर वो 120 डेटा पॉइंट्स में कुछ वैल्यू मिसिंग है ना, तो यहां पे लेट से एक वैल्यू मिसिंग होगा तो यहां पे एक दिखाई देगा. अगर 5 वैल्यूज आर मिसिंग, इफ यू हैव नॉट रिकॉर्डेड दैट डेटा, देन number of missing values will be 5. Clear, everybody? It is called N missing. Clear? So total number will be 120. Number of missing will be N dot. If you go back, actually it will a little deviation, but I'll go back again. If you go to statistics, here आपको दिखाएंगे, देखिए. Okay, can you see N total? N total will be 120 data points. Okay. N missing let's say in 120 data points, there will be some data points missing. Let's say one data point missing. Agar hoga, so non-missing will be 119. Are you clear with this? Just type yes in the chat box. So अगर कोई डेटा पॉइंट मिसिंग है तो आप उस पर फाइंड आउट कर सकते हो. दैट्स व्हाट आई मीन बाय दैट. ओके, क्लियर? चलिए आगे बढ़ते हैं, इसको बंद करते हैं. हाँ जी, सो व्हाट वी आर इंटरेस्टेड इन द मीन. क्लियर है? तो द मीन इज 42.106 मीन. वेयर इज द मोड? दिस इज द मोड. Can you see the mode? 41.2 is the mode. All right. And you can see here n for mode, meaning how many number of data points are there. So there's 7 number of data points for the mode. 7 बार repeat हुआ ये value. Highest value is mode. And where is median? Here is the median, which is 42.1. Okay. It is called the median value. Clear, everybody? Just type yes in the chat box. So mean, mode, median, we got it. Clear? Everybody? Any doubt? No doubt, right? Now let's come to the next three values. The first one is range. Range is highest value minus lowest value, which is 8.3. So range aa gaya yahan pe. Correct? The next one is variance. You can see variance over here, which is 2.707. This is sigma square variance, right? And the next one is standard deviation. Where is standard deviation? You can find standard deviation over here, which is the square root of variance. So if you take the square root of 2.707, you will get standard deviation as 1.645. Okay. So whatever data is there, go to stat, basic statistics, display descriptive statistics. You will get all the 6 values: mean, mode, median, range, variance, standard deviation. Clear? Just type yes in the chat box. Clear hai? Just type yes, 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 no, kuch doubt? Okay, fantastic. So this is the fundamental statistics which we use in our green belt level, and some statistics we use in the black belt level. Black belt level में थोड़ा हम लोग advanced statistics पे जाते हैं, but in the green belt level, this is the basic fundamental statistics we use. All right. So I'm open for the question and answer right now here. So to ask the question and answer, you can raise your hand. There is a raise hand option given over there. So you can raise your hand if you have any question about the today's topic or any other topic. You can, ask that question. Okay. Otherwise, we'll close the session. The recording will be uploaded within 1 hour from now. Okay. So you can check out the recording in Master Class Archive. Let me just type that for the new members. There is a folder called Master Class Archive folder. Okay. So you have to scroll down in the Masterclass Archive. At the bottom, you will find this recording with the title Fundamental Statistics and with the date given as well. Okay. So entire recording, if you want to revise, you can increase the speed as well. Okay. You can put it to 1.25, 1.5, 2x, whatever speed you want. You can quickly revise the content or to the specific content. There is a AI, nowadays there is AI also we have incorporated. So you can ask to that AI a specific doubt over there. That AI will give you the answer, and that AI will give you exactly that frame of the video where that doubt is there. Okay. So a lot of improvement in our LMS systems are also happening. Okay. And in between, if you have any doubt, this is the number for the mentor. Okay. So everybody, please, all the new members, please save this WhatsApp number. And this is not strictly for the calling. This is for the WhatsApp messaging only. Okay. So wherever you have doubt, okay, what you can do is make a list of the doubts and send all the doubts on this number, and our mentors, whenever they get their time, they will respond to that. Clear? It's a common number. This number, I also have this number. This number, other mentors, other team members also have this number. Okay. So whenever whoever sees this first will respond to that. Be a little patient. whenever you ask the question. Maybe within 1 hour, 2 hours, we will respond to that query. Clear? If you have any doubt, you can raise your hand or yeah. When was the date of the first session for this batch? Okay, there is no batch as such. Okay. There is no batch, there is no missing sessions. So every time when we will be there, we will be basically taking basic sessions, some advanced sessions, but all the sessions are required for you to complete green belt and the black belt. Okay. See, the very simple sessions we don't take because they are very easy for you to understand. आप वो course देख के भी आप समझ सकते हो. But these certain things where Minitab is there, hypothesis, regression, design of experimentation. Okay. These kinds of graphical analysis, all these tools, Minitab, advanced Minitab sessions, all these tools basically we cover in the live sessions because that's where your more and more practice is required. Okay. So sessions are not in the sequence and there is no batch as such because every day people join in our community, but do not miss the live session because it is so interactive. Are you getting some value out of this live session, guys? Are you getting some value, some insights, some deeper understanding of the same concepts? Yes or no? Correct? Yeah. That's why I always urge, even though you have completed your black belt, master black belt, see, the first time you attend for learning. Okay. Second time, how do I implement this concept? And the third time you attend this, how do I teach this concept for my team members? Okay. So always remember this LIT principle: learn, implement, and teach. That will upgrade your skill set faster. Okay. Yes, Prasanna ji, you can unmute yourself and ask the question.
Hello.
Yes.
Am I audible?
Yes, audible. Audible.
Good evening, Dhireshji and all my co-participants. My question is, when we are talking about central tendency, with respect to me, we come across many tolerances in our day-to-day, where we want it only at one side. That means, I can give an example: surface finish, where we say it is only maximum 3 microns, or 2 microns, 5 microns. So, for me, whatever the lesser is the better. In this type of tolerances, where the lesser is better, how do we really do the analysis of dispersion, deviation, capability? Is there a specific method, or
Yes,
can we apply all the basic rules?
correct. Now, today's topic, what we have covered, is all about once we collect the data, okay, how do we find the basic, what you can say, parameters of the data? Okay, one is central tendency, and second is the dispersion. Okay, now the question what you are asking is about the process capability analysis. Now, if you have, it is called unilateral process capability. You have process capability only in one direction. For example, let's say, let's take a pizza delivery example. 30 minutes are free. So it's a unidirectional. If you, there is no lower limit. There is only upper limit, which is 30 minutes. Are you understanding? So it is called unidirectional specification limit. And this comes into process. Okay. That is next stage. After doing this, then we will put a specification limit and we check whether my process is capable or not. Okay. That is called process capability. Okay. So if you go to archive and search for the process capability sessions, okay, there are a lot of examples of that around that, so that will give you more clarity on that. Okay. Yes.
Okay, I will look into that. Thanks.
Yes. So please try it out and try on Minitab and just send a screenshot on the WhatsApp number, and our mentor will validate and mentor will suggest you any corrections as well. Okay.
Okay. Thank you.
Yeah. Yes, Mr. Paras, go ahead.
So when we take the variance, we are doing what we are doing. We are taking square to make it positive. The negative numbers to be converted into
Exactly.
positive.
Correct.
Right?
Correct.
Why we are not taking the mode of the negative numbers? Means if it is -3, we can take it as a +3. Why it is necessary to take the square?
Correct. That's a very good question, by the way. See, that is also calculated, by the way. It is called mean deviation. What is called mean deviation?
Sorry?
In the mean deviation,
Hmm.
it is called mean deviation. Mean, MEAN, mean deviation. What
Hmm.
is mean deviation? In the mean deviation, we only take the absolute values of the distance and
Yeah.
not the minus and plus. Okay. Now, what happens here is uh, the comparison between the mean deviation and the standard deviation, statisticians give more weightage to the standard deviation. The reason being, say, understand this, standard deviation is a measure of variation, right?
Hmm.
And more the distance, we all know that more the variation, more is the rejection. We all know this, right? Because the
Yeah.
spread is more, rejection will be more, right? Now, the mean deviation is calculating the absolute distance. But the
Yeah.
standard deviation, it is giving the squared value of the distance. As the
Hmm.
distance increases, we are actually taking a squared value of that, and that is a little magnified than the mean deviation. Are you understanding? Can you comprehend this?
Yeah.
Okay, just try to comprehend. So the standard deviation is the magnified way of showing the deviation. That's why statisticians give more weightage to the standard deviation rather than mean deviation.
Instead of mean
It's a very
deviation.
good question, by the way.
Now I have one another question.
Yeah,
See,
but just point number one. Have everybody understood the explanation I've given? Just like yes, even though Mr. Paras has asked this question, this is very important for us to understand. Why not the absolute values taken and why the squared values? Because squared values gives us that magnifying effect. As we go away from the mean, we get a square. Imagine 10 as a value and 10 square as a value. Can you see the magnified effect what we are getting? Okay, that's the only reason statisticians suggest go for standard deviation. Yeah. The second question, please.
another question is that, as you said, that standard deviation has the same unit. Like
Ah,
if I am collecting data in the centimeter, then standard deviation is also in the centimeter,
hmm.
right? Because once we are doing square and then after we are again doing it a square root.
Well,
So
correct,
if I am collecting the data in centimeter, when we
correct,
are doing square, it will be a centimeter square, and when
correct.
we are doing again square root, it will become a
Centimeter.
square root, right?
Perfect,
But
perfect.
at the same time, what we are doing, we are square rooting the number of datas. Means if there are 100 datas, what we are doing, we are square rooting the variance, right? And
Correct,
variance also has this in denominator there is a number of datas. So
correct,
when we are doing square root, we are also doing the square root of number of datas.
correct, correct.
So
Because we are taking this.
so how the
So see, understand this. We are taking the average distance. This is the average. Understand this.
hmm,
Okay. So we have taken the square of the distances, and then we have taken the average of the distances.
hmm.
Okay.
So in
And
that
this is a
case, square root
squared.
should be on the in the nominator only, not in the denominator.
No, we see. Standard deviation is what we want to take the average distance from the mean. It's very simple.
Yeah,
It is simple. See,
correct.
actually, technically, it's a wrong definition. It's not the average distance from the mean, but for a layman's language, it is the average distance. Now, when
Hmm,
we take the average, we have to take the denominator, the number of data points as well, right? Correct.
correct. Hmm,
And because we have taken the squared value of the average, we have to take the square root of that average. It's a complete average to average square rooting we are doing. That's the reason it is taken the square root of the entire value and not only the numerator. I'm coming, I can understand from where you're coming, but this is the explanation for that. Because we are taking the average distance of that, that's why we have to take the square root of the entire average as the entire unit.
So
Okay?
in that case, if I have 100 data points, right, and I
Hmm.
am calculating
Yeah,
distance of the all data points from the mean, and then after I will take the
correct,
square, and then after I will divide it by 100 and take the square root. That means I am
correct.
dividing the whole square value, sum of the whole square value divided by 10 only, not by the 100, because the 10 is the square root of 100. See,
No, 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 no,
hello.
no. We are no, 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 no. No, 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 no. We are first dividing by 100 and then we are taking square root.
And then
Understand
we
this.
are
What you are
taking
doing
the
is
square root in.
you are you,
So
no, no,
when
no, no.
we are
You are
taking the
taking the
square root,
numerator square root differently and the denominator square root differently.
so denominator
हाँ.
में भी तो square root आ गया ना.
First we take the average and then we
Yeah.
take. No. First we take the average. I'm coming back again.
Yeah,
Go
I
step by
got
step.
it.
Okay.
First we take the average.
First we take the average. In the average, you have to divide by 100. Correct. In the average, now what you are doing is taking the denominator का square root. No. Here we have to first calculate the average. उसको square root लेना है हमें. That is the reason we have to not take square root of the numerator separately and denominator separately. Are you understanding? समझ में आ रहा है डिफरेंस? आपको एवरेज का स्क्वायर रूट लेना है.
ओके,
आप एक बार करके देखिए इसको.
ठीक
है, एक बार करके देखिए, एक डेटा लीजिए, आप करके देखिए क्या डिफरेंस आता है ना, एंड देन वी विल डिस्कस दिस. ओके, बट वेरी गुड दैट यू आर थिंकिंग इट डीपर. ओके, दैट इज अ वेरी गुड साइन. ओके, वेरी गुड. Any other question? Any other question? No,
it's okay. Fine.
Okay. Good. Super. चलिए, so thank you very much for joining in. ऐसे ही questions को even on the WhatsApp number also भेजा करिए. Okay, and we will have these kinds of discussion that will make our understanding also deeper in the concepts and application. Do not just understand the concepts, understand the applications of the concepts as well. Okay, so whenever we learn standard deviation, collect your own data and calculate the standard deviation, calculate the mean, median, variance, mode. Okay, that will give you confidence, and that will take you to the next level. Okay, so on this note, let's finish this session today here. We'll connect again with the next session with the next topic.